All right, so let's kind of. I'm going to kind of go about doing this um, in the best way possible, and I feel like I actually screwed that up. The previous one. What I did was I did 100 times 1.015 to the 1/4 t, and I kind of feel like yeah, that that's the equation you would use if you're still using this as a function of time, or as a function of quarters. But really the equation I should use is 100 times 1.015 times 4y, or to the 4y. Now what's the difference there? Okay, well here's what it's saying, all right? The 4 represents how many times this thing is compounded, right? And in our previous equation, we had this thing going 4 times a year. Does that make sense? So if I wanted to say, okay, this is the the amount of money for every year. If I plugged in 2 over here, then really this should be to the 8th power. Does that make sense to you? Yes, no, I don't know. Okay, because you need to say, all right, well, if it's 2 years, that means it's 4 times every year. So that would be 8 times in 2 years. So really, I should have brought this to the this is the number of times compounded. And this is the years, or the time that it's relevant. Okay, so let's break this equation down. All right, what was the 100? What did this represent? I'm kind of taking a survey of everything we've learned, because I'm going to show you this equation, and hopefully you'll know that I didn't just pull it out of thin air and make it up. What did the 100 represent? The starting amount, exactly. I'm going to call that. Let's see, starting amount. And I have a very special name for it. I'm going to call that principal. That's how much you put in at the beginning. Cool? What does the what does the 1.015 represent? This one's a little bit kind of confusing. Where do we get that? That was the interest. And it wasn't exactly the interest. The interest was 6%. It's kind of the interest. Let me show you where that comes from. The interest was 6%. Where did we get 0.015? Or the interest was 6%. This thing looks like the interest is 101.5%. Okay, Elijah, this is a question for you. Where did we get, actually, Elijah's still here. Elijah, where did we get the 100 part of it? If you don't know, say IDK. Come on, you guys. All right, where did we get the 100 part from it? Where did we get that part? Yes, exactly, Cougar. Because that would be taking into account the full amount of your starting money. Now, if I told you we didn't actually use 1.5%, we used 6%, but how did we get the number 1.15? Well, we took 6%. 6 divided by 4. No. It's the 6% divided by 4, right? Because it was 6% total, but I'm analyzing it 4 times a year. So each time I analyze it, it's 1.1.5%. Cool? If I analyze it 12 times a year, that would be 6% divided by 12, which is 0.5% a year. Does that make sense? So this number here depends on how many times, it depends on the amount of interest, yes, but it also depends on how many times you're compounding this interest. Okay, so here's what we're going to do. Let's do this. I'm going to show you the equation. Does everyone understand where each of these numbers come from? From this equation, each of those numbers. Okay, so here's the equation for compound interest. Write this down. A of t is equal to p times 1 plus I divided by n to the nt power. This is the compound interest formula. And even though that looks like a crazy equation, it's not really that foreign to you. This is saying the amount is equal to the principal times the parentheses 1 plus I over n. This is really just my kind of interest, the stuff inside the box. The 1 comes from Elijah's thing where you're adding it to the full amount. The I over n is the interest. It's the interest divided by the number of times you're compounding that interest over the year. The n times t, that stands for the number of times you're compounding it times the number of years that you're doing it. Does that make sense? All right, so here's my question. Which is better to do, so here's my question. Which would you rather do? Would you rather would you rather have 5% annually or 4.9% daily? Yes, I would rather have 4.9% daily. If we wanted to figure out how much interest do you get on 5% annually, well, let's try this. Let's put in $1,000 as our principal. So that would be 1,000 times 1.05, which we know as $1,050. We cool? Now, if we wanted to figure out, well, what is my total amount if I did it daily? Okay, well, that would be 1,000 So my A of t is equal to my P, which is the principal, times 1 plus, how much interest am I accruing? Well, I'm accruing 4.9% daily. So that would be 0.049 every 365 days. And I'm going to raise that to the 365 power times 1. Because this is after 1 year. Okay? You plug that into your calculator. Let's try it. 1,000 times 1 plus 0.049 divided by 365 to the 365 power. I don't need the times 1. All right, and I get 101 or 1050.22. Yeah, 22. Let's round it up. All right. So where do you get more money? You would get it in the 4.9% daily. How much more money? 22 cents. And you guys are thinking, that's lame. Like, why are we, why do you care? Yeah. Well, it will build up over a long time. And another thing, too, is what we would do eventually is move this thing up to being compounded. Like, what if we did it not just annually, but every second? Or daily. Let's do it every second. You see, now we're getting into some big numbers. Does that make sense? Now we're actually getting somewhere. In fact, what if we didn't do it every second? We did it every 3 times a second. Then we're going to start getting into some really cool stuff that's going to start happening, and you're going to see, wow, that's actually really interesting. All right, anyway, this is actually to the point where I wanted to get you to. And another thing, too, is even though there's a difference of 22 cents, if you put in $1 million in as your principal, the difference would be $217. I mean, you could buy a nice watch with that money. Or a pretty awesome guitar. Well, maybe not a full-on awesome guitar, but a good starter electric guitar with that extra money. I totally would rather have that. Does that make sense? All right, so let's try one of these problems, because I know I'm going to assign you these problems. Let's try a random one. Let's just do number... Okay, let's see. Oh, this is where you're comparing. 12% annually or 11.3% daily. All right. You know, all of these equations, all of these things are really just plugging in numbers into the correct, into the formula. So this is where your n is 12 and your I is 7, and that kind of stuff. So really, I think that pretty much finished off chapter 6. Let me just look ahead of schedule. Because I think that we actually got to finish. I got to start my next class. But that pretty much finishes off chapter 6 for a good majority of it, at least. We won't get into something new until we get to 6.4, which is what I'll probably cover next week. All right, I'll talk to you guys later.